Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Fox Ueng-McHale, and I am your host for episode 13, The Chemistry of Radiation Poisoning. Today, I will be discussing several chemical processes related to the effects of radiation exposure. Since the advent of the hydrogen bomb during the Second World War, radiation has quickly captured public attention. From medical uses to paint forgery detection, in one form or another, radiation can be found in almost every industry. But uncontrolled, radiation can kill. And it's this destructive potential that has dominated the public's perception of radiation. But what is radiation? In chemistry, radioactivity is the spontaneous breakdown of an atom's nucleus, emitting particles or waves. This is caused by chemical reactions. Here, atoms become more stable by participating in a transfer of electrons or by sharing electrons with other atoms. In nuclear reactions, it is the nucleus of the atom that gains stability by undergoing a change of some kind. This occurs as unstable isotopes shed. This radioactive decay is a reaction where a nucleus spontaneously disintegrates into a slightly lighter nucleus, emitting particles, energy, or both. One of the most important ways of measuring radioactive decay is the half-life. This is the interval of time required for 1/2 of the atomic nuclei of a radioactive sample to decay, calculated with the half-life formula. This is very useful for finding the time or mass of a substance at a given point. Shedding particles include alpha and beta radiation, as well as shedding protons or neutrons. The effects of radiation are horrifying, but surprisingly straightforward from a chemical perspective. Radiation poisoning comes in two classes, particulate and electromagnetic. Particulate ionizing radiation include alpha particles, beta particles, neutrons, and positrons. Gamma rays and X-rays are forms of electromagnetic ionizing radiation. Ionization is the cause of the toxic effects of ionizing radiation. Ionization of tissues creates highly reactive compounds. Radiation generates H2O+ and H2O- ions. In turn, these create H and OH radicals. Hydrogen and hydroxide ions are extremely reactive, causing massive biological damage, targeting DNA and proteins. Especially, ionizing radiation quickly kills rapidly dividing cells, targeting immature blood cells in bone marrow, cells lining the mucosa of the gastrointestinal tract, and cells in the lower layers of the epidermis and in hair follicles. Ionizing radiation is most harmful because it can ionize molecules or break chemical bonds, which damage the molecule and cause malfunctions in cell processes. It can also create reactive hydroxyl radicals that damage biological molecules and disrupt physiological processes. Moving into the future, it will be increasingly important to know how to combat radiation poisoning, especially as more nuclear power plants are commissioned in the future. In the event of a large-scale meltdown, having information about the effects of radiation will be crucial to planning a response. Thank you for listening to this episode of Chemistry Connections. For more student-run podcasts and digital content, make sure that you visit www.hvspn.com.